Hello everyone, this is Malik and on behalf of Azul and 451 Research, which is now a part of S&P Global Market Intelligence, I would like to welcome everybody and say thank you for attending today's webinar titled Keeping Java Current, Licensing and Upgrading Options. Just a few quick housekeeping items before we get started. To ask a question, simply type it in the question box on your screen. We will get to as many as we can during the Q&A session. As the presentation slides are available for the download in the resource section in the console. And finally, the on-demand version of this webinar will be available shortly after the live event concludes. Leading off today's discussion will be John Abbott, who is co-founder and a distinguished analyst at 451 Research. Joining John, we have Simon Ritter, who is Deputy CTO at Azul. We welcome our speakers today, and with that, I'll turn it over to John to kick off this event.
Thanks, Malik, and hello everyone, and thank you all for joining us this morning. I think it's going to be an interesting discussion. We're here to talk about keeping Java current and to discuss how Java is licensed today. What the options are available for customers now and how to think about your Java plans over the longer term. So our guest is Simon Ritter, and Simon, pleased to have you here. Would you quickly give us an idea of your background?
Yes, I've actually been involved with Java really right from the very beginning. I joined Sun Microsystems way back in February 1996, pretty much about the same time that JDK 1.0 came out. I sort of followed Java all the way through its history at Sun, through the various iterations, did a number of different roles there until we got acquired by Oracle back in 2010. I then spent another 5 years at Oracle doing pretty much the same thing, following the Java developments and so on. And then in 2015, I joined Azul as the deputy CTO, and I've kind of, again, carried on doing the same thing, which is following Java and the developments and overseeing various things around that sort of area.
Great, thanks. Yeah, one of my claims to fame is that I went to the first Java press conference and met there Bill Joy and James Gosling. So that was, yeah, I still remember that, even now. I suppose that was, what would that have been, 1996, would it have been? I don't know.
Probably, yes, or even may have been, even been 95, because I know they actually launched it in 95, so could have been there.
Right, yeah. Anyway, we've already started off with a bit of history, but perhaps you could just catch us up a little bit more. I mean, we're coming up to 30 years old now, and that's a lifetime in technology terms. So when it first came out, there was no such thing as, at least widespread virtualization with VMware and everything. That hadn't even been launched yet, and there was not really such a thing as cloud computing. So why is Java even still relevant today?
Mm-hmm. Yeah, it is an interesting question, isn't it? I mean, if you look at the history of Java, the very first thing that it was developed for was actually an embedded system, because James Gosling was asked to create the programming language for the Star 7, which was a sort of PDA, which today we would pretty much call an iPad. And so that was sort of the direction it initially took. And then when it was first released and the popularity kind of really kicked in, it was more about web-based applications. And suddenly you could include functionality and do things on a web page rather than it being completely static. But what's really sort of driven Java's popularity is that a few years after that, people started to think, oh, actually, we can use this in enterprise applications. And so we've seen that, with the introduction of Java Enterprise Edition back in, 1997, and then that sort of grown over time. And now we've got other frameworks that are very popular, like Spring and Spring Boot. It's really the enterprise side of things that has led to its popularity. And if you look at the architecture of enterprise Java, Java EE, that suits very well the idea of moving into the cloud, because it sort of breaks things up into components, servlets, and enterprise Java beans. And those you can sort of map more easily into the sort of microservice architecture, which is what people are using now. And so I think it's really the way that Java has evolved over those 30 years and adapted to changes in the way that people are developing applications, more importantly, the way people are deploying applications, which has maintained a lot of its popularity. And I'm sure we'll come back to this later, but I think also the fact that we have the JVM, this layer which sits between the application and the underlying platform, whether it's the operating system or the cloud or whatever. And that's one of those things that really does make Java very powerful. Sun had this idea of write once, run anywhere, and that's really kind of lived up to its name and is still very, very relevant when we talk about making cloud deployments. So that's, I think, why Java is still so relevant today. Its evolution and ability to adapt.
Okay, great. Well, so perhaps we could move on to Java licensing specifically. I mean, that's changed over the years as well. Sun, I think, in the 1990s, things were, as I remember them, relatively open and easy. Mm-hmm. But then or as you said, in 2009, Oracle acquired Sun, and I think we can safely say that Oracle is a somewhat more commercially minded organization. And I know there's been some changes recently as well, so perhaps you could talk a little bit about that.
Yes. So again, if you go right back to the beginning, when Sun released Java and people were able to download the JDK, the licensing terms that they used for that were very open. And essentially, you could use it for your applications for free pretty much anywhere. And the only exception to that was what Sun described as the field of use restriction. And that was for things which were embedded devices or single-purpose devices. So if you were making something like a ticket kiosk or something like that, that would count as embedded. And the reason that Sun did that was because in the early days, the way that they were actually making some money out of Java was through these embedded applications. And for those of us old enough to remember, before the iPhone, there were phones that had Java on them that allowed applications to be downloaded. So people like Nokia were very keen to use Java in their phones, and Ericsson and Motorola and people like that. So the licensing was very open with Sun. So if you wanted to use it on your laptop or your desktop or your server even, then there was no restriction. You could just use it for free. As you say, when Oracle took over, they looked at it in a more commercial way and took a more commercial approach to how they could monetize Java. And they didn't do that initially, but then we saw back in 2018, I think it was, that with the introduction of JDK 11, Oracle made a substantial change to the way that they licensed the Oracle JDK. Before that, they essentially used the same license that Sun did. It was called the Oracle Binary Code License, and that allowed you to use the Oracle JDK freely anywhere except for embedded applications. When JDK 11 was launched, they changed the license for the Oracle JDK to the Oracle Technology Network License Agreement. And that's much more restrictive about where you can use Java, the Oracle Java, freely. Essentially what it says is, rather than granting you sort of anywhere you want to use it, there are literally only 4 places that you can use it without having to pay for a support contract. And those 4 places are sort of development and testing, creating your applications. If you're using it for personal use, and if you're sitting at home playing Minecraft, which actually runs on top of Java, then you still get free updates that way. And for commercial users, it's either people who are using the Oracle Java environment to run Oracle-specific applications or running in the Oracle Cloud. So it meant that for people who were using it commercially for running their web servers or their application servers, suddenly, if they wanted to move to JDK 11 or later, they were going to need to use this different license and buy a support contract from Oracle. And then they also made a change sort of halfway through, if you like, so that JDK 8 became both using the old license and using the new license, because up to update 202 in JDK 8, which was January of 2019, it was using the Oracle Binary Code license, so you could deploy that for free, no problem. But from update 211, which came out in April of 2019, then they switched to the Oracle Technology Network License Agreement, meaning that you would need to have the support contract in place. So that means that people who've been using JDK 8 suddenly had to think, okay, we need to have a bit of a think about how we're going to continue using JDK 8 with updates for both security and bug fixes and so on. That's not quite the whole story, though, because literally last year when we had JDK 17 came out from Oracle, they introduced yet another new license. And this time they introduced a license which they call the no-fee terms and conditions license, which sounds like it should be free, but you do need to be a little bit careful about that, because that essentially says that you can use it for internal applications without having to get a support contract, but it's not really quite clear about what they mean by internal applications. If you're running a web server internally, but your customers are accessing it from outside, does that qualify as an internal application?
Right.
I would leave it to your lawyers or your users' lawyers to interpret that and decide whether that makes sense. The other thing that, just to add a little bit more complexity to this situation, is that that license is for JDK 17, and that is valid until 1 year after the next long-term support release. This was another change that Oracle made in terms of having only certain versions of Java have extended support, and they're called LTS releases. JDK 17 is the current one, and so they said that that license will apply for until 1 year after the next long-term support release comes out. That will be JDK 21, meaning that you would have 3 years of free updates, and then it reverts back to the Oracle Technology Network License Agreement, meaning you would then have to pay for a support contract if you wanted to continue getting updates to JDK 17 after that time. So yes, it is quite involved.
Okay, well, we'll come back in a minute to older versions of Javas and what you should do if you're on them. But I mean, I just wanted, to Oracle's credit, they didn't sort of abandon open source Java, and I wondered if you just talk a bit about OpenJDK and Jakarta and how those have evolved alongside the commercial versions.
Mm-hmm. Yes, you see, this was one of the things that Sun Microsystems did back in 2007, which was to essentially open source Java. There was a big push from the community, and Sun resisted that for a while, but eventually in 2007, the decision was made that they would actually make it open source. And they created the OpenJDK project, and they contributed all of the code that was necessary to build the Java development kits, the JVM, the libraries, a compiler, all of that. So it took a little while to get that all sorted out, because they obviously had a lot of checking to do to make sure they had the rights to the various code. But eventually we got to a point where OpenJDK, you can simply go to the relevant repository for the version you're interested in, download everything. Right now it's on GitHub even, so you can just do create the repo from there, and then you run the build scripts. It's all very straightforward, and you can create a distribution. And that's essentially what we've seen. We've seen a proliferation of distributions from the open source version of Java. And the analogy I like to use for this is it's very similar to Linux in many ways. Linux is an open source project. If you want to run your applications on Linux, then you need a distribution. You go to Red Hat, you go to Ubuntu, Debian, or whoever. Same thing applies with OpenJDK. It's an open source project, and then people will take that source code, build it, make it into an installable distribution, and then provide support around that. So this is very good, because it means you have a lot more choice in terms of who you can install your Java from, the same way that you do with Linux. Jakarta's a very similar thing, because, again, Oracle and Sun before them made the decision to open source all of this, and it's now part of the Eclipse Foundation. That's why it's changed from being Java EE to Jakarta, because of the issues around the branding and the trademark. But essentially, we still have the ability to build a distribution of the Jakarta application server. So you've got Glassfish from people like Pyara. You've got Red Hat have their own one, and various other people can provide application servers that you can run your code on. So again, it's having the choice of distribution, but from an open source project.
Okay, great. Well, and perhaps we could run through the main options for customers today, and some of the risk and compliance issues. And I think we've got three categories, haven't we? Stay unsupported, upgrade to a new version from Oracle, or go to the open source route. So, it's an urgent question, because the extended support for Java 7 has just finished at the end of July, I think. So can they keep people using Java 7? Can they keep running unsupported? What are the risks of doing that?
Yes. So, I mean, essentially, if you really wanted to, you could run unsupported software. You could take the last update that if you had a commercial contract with Oracle, as you say, the last update that they would produce came out in July. If you were using free versions from Oracle, then the last public update that came out was in April 2015. So that's quite a long time ago. Now, in terms of the risks associated with that, I really can't overstate the problem of doing that. Why I say that is because if you look at, and I did a little bit of research on this before the webinar, if you look at Java SE7, JDK 7 specifically, as I said, the free public updates ended back in April 2015. Since then, we have had 260 CVEs, and that's common vulnerabilities and exposures, that have been reported against Java JDK 7 specifically. Now, it's not other versions of Java, that's JDK 7 specifically. There are 260 CVEs that affect that. Now, it might sound like a lot. It is a lot. All software is, exposed to vulnerabilities. The more complex the software, the more likely there are vulnerabilities going to be in there. But that means that there are a lot of potential flaws that people could use if you were running from the last public update. Even if you're running from the last commercial update, there will be CVEs that are going to be reported against that as we move forward. So the problem you're going to have is that you're now running unsupported, which means that any vulnerability which is identified that will affect that particular version of Java is going to be made public at some point when vulnerabilities are fixed in the newer versions. And then people are going to go, ooh, let's have a look for somebody who's running an older version. Now, again, I can't overstate this enough about the potential danger of doing this. To use an example of how that can be very dangerous, I look at the Equifax example. Right. Go back to 2017, and Equifax were running an external web server for credit scores and dealing with resolutions of issues on there. That was using a Java framework called Apache Struts. And back in March of 2017, there was a CVE that was identified in that which would allow people to run remote code execution. In May of 2017, Equifax had not updated their Apache Struts implementation. And that resulted in people finding a system which had that vulnerability exposed, and they were then able to exploit it. That resulted in them extracting 165 million records of users. So that's your credit history, your name, your address, your social security number, all sorts of things like that. And that was because the system wasn't actually patched. So even though it wasn't the Java platform itself, it was a Java library running on top of that. As I say, running unsupported software, if you're dealing with any kind of sensitive information, then it just isn't worth not running supported software. So that's what I would say about that one.
Right. So Oracle's specific advice for Java 7 users is to upgrade to another, as you said, long-term supported version. Like I think SE8 is supported to the end of 2030, I think, and SE11 till the end of September 2026. So what are the pros and cons of taking that course?
Yes. So the idea of moving to a new version obviously can be very appealing, but there are certain things that you really do need to consider with that. Now, as you rightly say, you've got JDK 8, JDK 11, JDK 17 are all currently supported long-term support versions. But if you were to say, okay, I want to continue using the Oracle Java, then the only one that you could use right now without having to pay for a support contract would be JDK 17, because that's covered by the no-fee terms and conditions. Assuming that you're happy with the way that license works in terms of internal applications, that would be the only one you could move to freely. Now, the issue with moving from JDK 7 to JDK 17 is that you're making a big jump in terms of the number of versions. It's literally 10 versions that you're moving forward. Normally, that's not a huge issue with Java. Java has extremely good backward compatibility support. So you can take applications that were run on or written on like JDK 1.2, for example, take a simple application and run it on JDK 17 without any issues, without even recompiling it. But if you're running an enterprise application, then most likely you're going to be using frameworks like Jakarta, like Java EE, maybe Spring, something like that. And that's where things become more complicated, and especially if you're moving across the JDK 9 boundary. The reason I say that is because with JDK 9, there were some big changes in how Java was packaged, if you like. It was around what's called modularity, breaking up the libraries into modules, but more importantly, the encapsulation of internal APIs. So there are a lot of APIs inside Java that were never supposed to be used by developers, but lots of developers did use them. Most famous of those for people who've done development is called Sunmisk Unsafe. I really like that one because the clue is in the name, unsafe. Don't use it. But a lot of these frameworks and libraries have used these. And so if you're trying to move from, say, JDK 7 to JDK 17, then you are faced with having to do a lot more migration work because you need to identify if these libraries have used these internal APIs. Then you need to add specific things to your startup script to enable access to these APIs that are now hidden where they weren't before. And so there is a lot more work. Even a move from JDK 7 to JDK 8 would involve a lot of testing just to make sure that your application works in exactly the same way that you expect it to. So if you can leave it on the same version, that's the preferred choice because obviously you're not changing anything underneath. Migrating to a new version has these drawbacks in terms of how you go about either doing all the testing or looking at the changes you have to make your code work.
Right. Okay. Great. Well, so we go on to the third main option after remaining unsupported or upgrading to a newer commercial release from Oracle is to go open source, go to the open source route using a distribution with support from another vendor. Should customers find that possible to do?
Yes. So this is, in many ways, the simplest solution, which is to say, okay, we have our application. Let's take JDK 7 as an example because that just changed. So we're running JDK 7 application. It all works fine. We're very happy with it. There are no issues with that. Everything works. We don't want to mess with it. So rather than just continuing to run it and potentially being exposed to security flaws, having to go through the problem of migrating it to a newer version of Java, just use a different distribution. Again, using the Linux analogy, we'd be moving from, say, Red Hat to Ubuntu or Ubuntu to Debian or whatever. Now, that is a much simpler thing because you're running exactly the same version of Java, so there are no issues from a functional point of view. You don't have the details of modularity and internal APIs and things like that. And then you can continue to use that so long as the provider of the distribution continues to support it in the sense of backporting the security patches and bug fixes from the current release to that older supported version. And in the case of Azul, we're literally the only company that still does that. So we have versions of JDK 7 and even JDK 6 that we can provide to customers so that if they are running applications on these very old versions of Java, then we will provide the regular quarterly updates that you would get for the other long-term supported versions, 8, 11, and 17, with all of those bug fixes and security patches backported where applicable. It's important to say where applicable because obviously if you've got a feature in JDK 17, for example, that doesn't exist in JDK 7, then there's nothing that we can backport because there isn't anywhere to backport it to. Anything that exists in JDK 7 that does exist in JDK 17 will make that change so that you have that security patch, you have the bug fix and so on. Then we'll do the building of that and then we'll allow you or allow it for download. Do that on a quarterly basis. So you can essentially continue to run your application in exactly the same way that you did before with the knowledge that you've got those security patches, so you're not facing the problem that Equifax did, because you can deploy those patches in a timely manner. You can then make sure your systems are as secure as possible, as stable as possible, and keep your applications running. So it's the minimal set of changes from a deployment point of view.
Okay, and we're talking about quite a few customers here, aren't we? So I think I read somewhere that 15% of Java users are still on Java 7 and Java 6,
yes.
Still quite a few of those? Yeah.
As you say, I mean, Java's nearly 30 years old now. And so lots of people have deployed lots of applications over that period of time. And because many of these applications are no longer being developed, they're no longer being enhanced, but they're still, core pieces of functionality, they're still important to the running of an enterprise, then people will want to continue running them on the older versions. And so, as you say, there's a very reasonable percentage of organizations that are still running applications on both JDK 6 and JDK 7. I mean, I even come across customers who are running code on JDK 5 or 1.4.2. We can't help them because that's before Java was open sourced, so there isn't the ability to maintain those versions. But from 6 onwards, then yes, we can still provide updated versions of those.
Right. So how should customers be thinking about their longer term plans? When should they stay on one of those older versions of Java, and when does it make sense to or become really important to migrate to a newer version?
I think there's two things to that. One is, how long can you actually continue to use that particular version of Java and get access to those updates? Now, at the moment, we're saying that we will continue supporting both 6 and 7, providing updates to those until 2027. So you've got another sort of 5 years, another 5 years to be able to use those. So that gives you a nice sort of timeline to think to yourself, okay, yeah, I don't have to worry about this for 5 years. But I wouldn't recommend saying to myself, okay, I won't worry about it for 5 years, and then in 4.5 years think to myself, ooh, I really need to get onto that now. It was one of those things where that gives you a nice window of opportunity where you don't need to worry about this, but it's certainly something to think about, because there's lots of other things. If you move to a newer version of Java, then you can take advantage of the changes that have happened since the old versions are released, specifically around things like performance. The JVM will just perform better because they've tuned it more and they've added more things to it, plus the ability to do different things in terms of the way that the code works and stuff like that. So there are advantages to moving to a new version, but it has to be done in a way that suits your organization, so that you're taking those applications and moving them when it makes sense for you as an organization to do that in a timely manner. So I think it's one of those things where you say, okay, I know I've got 5 years. We need to think about a plan as to how to move things forwards in that sense.
Okay, so I want to get on to slightly newer developments, new technical developments and the optimization of Java for the cloud. You talked earlier about how some of the modularization of Java has played into sort of cloud technologies, and some people are now talking about cloud native Java. So what should customers be looking out for, especially if they're working on the cloud, and how do they get access to those newer developments?
Yeah, this is one of the things that we do see a lot. And there was an interesting report that was done recently by Andreessen Horowitz, so one of the venture capital funds, and they came up with what they called the $1 trillion cloud paradox. What they were talking about there was the idea that people look at the cloud as a utility-based pricing model, and you pay for what you use. So rather than having to provision your whole data center and decide how many machines you need and then install them, buy them, and maintain them and so on, you let somebody else deal with that problem. And you take your applications, you take them out of your data center, you move them into somebody else's data center in the cloud, and that will save you money, because now you're only paying for what you use. You're not having to over-provision to deal with peaks in load. You can dynamically change how many systems you've got, dynamically change it up and down. So it should all be very good. You can now save money by using a utility model. What people often find is that doesn't happen. They do a lift and shift of the application where they take it out of their data center, move it directly into the cloud, and suddenly they find it's actually more expensive running it in the cloud than it is in their data center. And that's because they haven't approached it from the idea of how do we architect our application to take advantage of the utility-based pricing model in the cloud. One of the key ways to do that is to move from a monolithic architecture to a microservices architecture. So you break it up into discrete components that interact very closely. And by doing that, when you need to increase the resources that you've got available to a specific part of your system, so let's say you've got one service which becomes a bit of a bottleneck, then you can simply create more instances of that service and then do load balancing across those so that all the other parts of the system then get the response time that they need. But it's essential that you do some re-architecting for the idea of moving into the cloud so that you can take advantage of these things. So that's one kind of big thing. But then the other thing which we at Azul have been looking at very specifically recently is the idea that even if you move to a microservices architecture, this is great because you've got the idea of loosely coupled, highly cohesive services. So they work together, but you can change them very easily, but they're very tightly coupled in terms of how they work together. That's great at the application level, but the problem is if you look at the Java level, all you've got is individual Java virtual machines which start up those services, they run them, they do whatever the service needs to do, and then they get stopped. But there's no shared knowledge of what's happening at that Java level. And in the cloud, we should be able to take advantage of that. What we've done is say, okay, let's look at those JVMs and how can we improve that by understanding what happens in the cloud and the way the cloud works. To do that, we've said one of the key things that the JVM does for your application is just-in-time compilation. You have bytecodes that need to be interpreted, the write once, run anywhere idea. That's great because it means that you can compile the code as the application's running, which means that you have a complete view of how the application is working, profiling information that allows you to optimize specifically for the way the application is working. And that's different to what you get with static ahead-of-time compilation. So it's better performing. But the problem is that every JVM has to do that itself. And every time you start the same service, it does the same thing. So it has to learn which pieces of code to compile, has to compile, and so on. What we've done is extract the just-in-time compilation part out of the JVM and turn it into a centralized service. So JIT as a service, if you like. And we call that the Cloud Native Compiler. What that allows us to do is to say, right, when you start up a service, a new service, that needs to compile code. It sends a message to the centralized service, says, here's the code I want compiled, you compile it. It then gets back the necessary instructions which can run as the service is used. When you start up the same service and it needs to compile code, it goes to the Cloud Native Compiler, but this time the Cloud Native Compiler goes, oh, I've already compiled that, so I don't have to do the work again, straight back with the compiled code. And if you start up the same service again, you take advantage of that caching. The other thing that provides a big advantage for is that you now don't have to provision the resources in the service to do that compilation. If you're using something like a Docker container and you've got 2 vCores for that particular container, what you'll find is as it does the compilation during the running of the application, it will take away the resources from the application. So it may use one of those vCores to do compilation and one of the vCores to do the work of the service. So you're effectively reducing the capabilities of that service by 50% because it's doing compilation. Move that into a centralized service. Now you don't have to use the resources you've got in your container to do the compilation. It's external. You can make those resources smaller and cheaper for your services. So there's a lot of benefits to centralizing the compilation side of the Java virtual machine. And so that's the kind of the thing that we've been working on most recently in terms of providing better ways of Java to run in the cloud.
Great. Sounds really interesting. Anything else? Any other issues you want to touch on? A few I thought of was security, for instance, ongoing security issues, or maintaining compliance, or using Java across multiple platforms like cloud.
Yes. Yeah, compliance is a big one because obviously there are lots of people running applications in specific vertical industries, and it's not just finance. It is things like utilities have compliance that they need to work within for their IT systems, and so it is very important for a system to be in compliance. Most of them. One of the key things is that they have to be kept up to date in terms of all available patches, and going back to what we've already talked about in terms of making those updates available on the quarterly basis as Oracle do for each of the versions of Java, then if you want to continue using one of these older versions and be in compliance, then you need to make sure that you are running supported software, and therefore you need to find a distribution that will make those available. And it's also quite important to think about the timeliness of how quickly those updates are made available. Each quarter, Oracle will release an update to the Oracle JDK, and then it's how quickly do you get those updates after that. I mean, if it's going to be like within a couple of hours, then clearly there's no issue. If it's going to be a few days later, that could be a big enough window for somebody to find the vulnerability that's been reported, develop an exploit, find systems that can be attacked, and then do that. If it's going to be a couple of weeks or even longer, then that window becomes bigger and the chances of your systems being compromised becomes higher. So really what you're looking for is a provider who can come up with those updates very, very quickly after the default update is delivered from Oracle. So that's sort of the security and the update side of things.
Right.
Yeah.
Okay, great. So I suppose really just to sort of round things off a bit, is the future of Java secure? Do you think it'll keep its relevance as an enterprise platform now that there are other fashionable languages available, and when so many other things are changing?
I really do. I mean, if you look at the way that Java continues to be very popular, it's always in the top 3 most popular languages in the sort of surveys that get done. I do like to point out that it's also normally in one of the most hated languages as well. But then, as I think it was Bjarne Stroustrup, if I can't really pronounce that properly, the guy who invented C++, he had a wonderful quote where he said there's only 2 types of programming languages, the ones that are popular and the ones that people hate and the ones that people don't use. So it's one of those things where Java is both very, very popular, but people always have issues with it because it doesn't do things quite the way they want it to. But that said, one of the great things about how Java is being developed now is this 6-month release cycle for the JDK. And that means we are seeing changes coming through at a faster rate than we've ever seen before. And that's allowing the development of the platform to address the needs that a lot of developers have as they change the type of applications. So microservices as an example, we're now seeing more things coming through to make it easier for developing in microservices. And you mentioned the idea of competing languages. Again, coming back to this idea that we have the Java virtual machine, that's really the power of the Java platform. So even if you want to use a different language, you could use something like Kotlin, you could use Scala, you could use Clojure, depending on what type of programming language you want to use. And you can compile it into bytecodes, which means you can run it on a JVM in exactly the same way as if you'd written it in Java to start with. So there's a lot of flexibility in the Java platform, both from the pure Java side of things, but also in terms of having other languages that compile into bytecodes and addressing the needs of the users. So yes, I definitely think that with the core Java platform, plus things like Jakarta, MicroProfile are coming through now. It's been around for a while. Spring Boot, Spring, very popular frameworks like that, which make that higher level enterprise development much, much simpler. Again, it's addressing the needs of developers and making their lives easier, so it will maintain its popularity.
Great. Well, thank you very much, Simon. A really interesting discussion, I thought. And I'm going to hand it back over to Malik, our moderator, who will, I think, sort out some questions if there are any. Malik.
Thanks, John. It's now time for our Q&A session. Just a quick reminder, if you have a question, simply type it in the question box on your screen. The first question I have is, I am still on Java SE 7. Should I consider an upgrade to SE 8 or to another long-term support release, or is it okay to stay on SE 7?
Yeah, I think we've probably talked about that quite a lot as we went through. And I think it really comes down to what level of work you're prepared to go through in terms of making the changes. So the simplest option, as we said, is to stay on Java SE 7, find somebody like ourselves, Azul, who can provide you with those scheduled regular updates, meaning that you can continue to use Java 7 as the platform for running your application. You don't have to change anything. But if you're prepared to do a bit more work, then moving to a newer version of Java, which would obviously, if you move to Java SE 8, then you're going through a testing phase and making sure that everything works in the way you expect it to. If you want to move to an even newer version, then the work becomes more, because of the fact you've got to then start looking at, are you using frameworks or libraries which do step outside of the standard Java APIs, and then you've got the migration work that is required in terms of addressing the changes to the core Java platform. So there's different options, but the simplest is definitely to stay on Java SE 7 and just use a supported platform.
Thanks, Simon. The next question I have is it possible to migrate gradually? What are the issues of using multiple Java versions?
Yes. Yeah, I think the answer to that is most definitely yes, because if you've got lots of different applications and they're running on different versions, it really doesn't matter, because so long as the application itself is doing what it needs to do, then externally it shouldn't really matter at all which version of Java is being used underneath. So long as the service works, so long as the service delivers on what it needs to, then you shouldn't really care. So there is this sort of isolation, which means that if you've got sort of different applications and you want to do that migration gradually, then you can certainly do that, because you can say, right, what are the most important ones? Let's focus on those first. Let's get those moved forward to a newer version. Let's go through the issues that, and that will also help you to learn as well. You can then understand what are the things that you need to look at specifically with the applications as you do other ones, and then as you've done the first few, you start to learn, and it becomes easier as you start going through the list that you've got of all the other applications. So yes, I would definitely say that doing a migration gradually is probably the best approach. In fact, trying to do everything at once is probably going to just cause you a lot more problems than doing it gradually.
Thanks, Simon. The next question I have is, who is driving new Java developments now? Is it Oracle, the open source community, or other Java companies?
That is a very good question. So the way that things work is that there is the OpenJDK project. So that is the area where Java is developed in terms of the source code. And that is developed via what are called JDK enhancement proposals, or JEPs. Anybody who is a member of the OpenJDK community and has the appropriate level of status can submit a JEP. And so essentially that means that you need to be a committer on the OpenJDK project, and then you can submit an idea for a JDK enhancement proposal. That means that the majority of those will come from Oracle. Oracle have the biggest engineering team in terms of developing Java, and a lot of the core ideas are driven by the architects of the OpenJDK, people like Brian Gertz, people like Mark Reinhold, who have the sort of control of that. They work for Oracle, but they're also in the OpenJDK project. So it is done through the open source project. Oracle will be the main contributor of those ideas, but we do get lots from outside of Oracle. Azul actually were the first company outside of Oracle to submit a JEP and have it accepted and integrated into JDK 9. Since then, we've seen some from Google, we've seen some from Red Hat. So there are some bigger projects, things like Shenandoah. If you looked at things like garbage collection, that was a big project that Red Hat came up with, and they've integrated that into OpenJDK. So there's a lot of work that happens around the OpenJDK. different companies that provide the input to that. So as long as you've got committer status, you can suggest something. Doesn't mean it will get in, but you have the right to suggest it, and then people can review it and decide whether it should be included in the Java platform.
Thanks, Simon. We have one last question. The question is, are there any problems or issues that come with running Java in the cloud?
Not really. There are a couple of things to be aware of. If you are using older versions of Java are not necessarily what I would describe as cloud aware. What I mean by that is that if you're running a JVM within a container, the container relies on C groups and relies on the resource management of the underlying operating system. So it uses what's in the Linux kernel, for example. And if you were using, let's see, I have to remember the exact versions for this, but if you were using JDK 9 or earlier, and then if I remember rightly, probably somebody will correct me on this, but I think it was JDK 8 update about 180. Prior to that, the Java virtual machine, when it looked at the resources available to it when it started up, it wouldn't look at the ones that had been configured for that C group. It would look at all the resources that were available in that particular machine. The effect of that was that if you had a container that said, right, I only want it to have 2 vCores and let's say 8 gigabytes of memory, but it's running on a machine with 40 vCores and 128 gigabytes of memory, when the JVM starts up, it's going to go, oh, I've got 40 vCores and 128 gigabytes of memory, and configure everything to run on that platform. Suddenly, when it tries to use all that memory and tries to use all those vCores, the C group will restrict it, and that can actually end up with situations where you get an abrupt stop of your VM because it gets an out-of-memory error. That has been fixed, so now the VM is cloud aware, C group aware, so it will work quite happily. And there's various other things that that are happening in the OpenJDK to make life a little bit more easy for deploying in the cloud and in containers specifically. So that's just kind of one thing that I can think of off the top of my head. If you're using older versions, that it might be an issue.
Thanks, Simon. We just received another one, so I'll squeeze it in. The question is, some cloud vendors have their own Java implementations. Are these tied into their cloud services, Oracle Cloud Infrastructure, AWS, etc.?
Yes. So as you say, if you look at the different main cloud vendors, you've got AWS. They have their own Java distribution called Corretto. And then you've got Microsoft, who on the Azure cloud, they used to use Azure's Zulu. They've subsequently started doing their own distribution, which they use in the Azure cloud. It doesn't actually have a name. It's just called Microsoft Java. Now, that wasn't because they were unhappy with what we were doing with Zulu. It was just that they wanted to bring their build of the OpenJDK in-house so that they weren't affected by things like the Solarflare issue that had been seen before. But and Google have their own one as well. Now, in the case of both AWS and Microsoft, they make those versions, well, in fact, all of the cloud providers make those versions available free for use within their cloud and with the updates and with support. Obviously, some of those ones also make it available freely outside, but doesn't come with any support and doesn't come with guarantees about how quickly you'll get updates and so on. So there are options in terms of running things in the cloud. But as I say, in terms of what we've been doing for the things like the Cloud Native compiler, that's a bit different. So you may still want to think about using a different Java implementation in the cloud to get different performance characteristics and profiles and so on.
Thanks, Simon. That concludes our webinar for today. Thank you, John and Simon. As a reminder, the on-demand version of this event will be available shortly. On behalf of Azure and 451 Research, thank you for attending and have a great day.
Thanks very much.
Thank you.
Bye.